Hey everybody, just in case the language isn't clear, what I mean, this would be an example. 1/3 is what I would call an odd reciprocal, and then 1/5. And this is an even number of odd reciprocals, namely 2 odd reciprocals, right? Well, this certainly does not equal to 1. Now, but maybe there's enough, you could add enough to where it would be equal to 1. So we're going to set out to prove whether or not that's a possibility, okay? So this is another way of saying it that perhaps is less ambiguous. Put another way, let E be an even number, and we're given E odd positive integers, which is what the problem is trying to convey, okay? Now, and again, what this means, of course, is each of these n sub i's is in the form 2, we'll just say, we'll call it k sub I also, we'll index that integer also. 2k sub I plus 1, which is just the kind of the canonical definition of an odd integer. Okay, it's an even integer plus 1. Okay, so we've written the sum. Okay, we've written the sum of an even number of odd reciprocals. Okay, so this is also a form to be looked at. We can make some progress by multiplying through by the product of all of these odd integers. Okay, and this is sometimes called clearing the denominator. So if we multiply 1 by the product of all these odd integers, we just get the product of all these odd integers, okay? Now, it's very clear that this left-hand side has to be odd, right? Because the product of any number, any quantity of odd integers has to be odd. If you just think about the form or modular arithmetic, 2k plus 1, 2ki plus 1 times 2k, you know, I mean, if you multiply a bunch of odd numbers together, you're always going to have a remainder of 1. That 1's going to be dangling at the end of the multiplication, okay? So the left-hand side is clearly odd. Now, what about the right-hand side? Now, notice we did get the right-hand side. Notice how this n sub 1 cancels with this n sub 1. This n sub 1 right here cancels with this n sub 1. So the very first term doesn't have an n sub 1 present in it. And in a similar fashion, n sub 2 cancels with n sub 2, and we don't have an n sub 2 here. Okay, so what we have is an even product of a bunch of odd numbers. In other words, it's an even, each term in the product is odd. Each of these individual terms, like this one would be odd, right? Because again, we are talking about the product of odd, just like over on the left-hand side, okay? So this one's odd, this one's odd. That is, it leaves a remainder of 1 when you divide by 2. Okay, all the way across, every one of these are odd, but there are an even number of them. Okay, and the very last one is odd. Notice how the very last one canceled here. N sub E cancel. So anyway, what happens when you add up an even number of odd numbers? Okay, well, that's certainly even, right? The whole thing is even. So this entire right-hand side is even, contradicting the parity of the left-hand side, which is odd. All right? And I think that's clear enough, right, folks? Just a simple example. If you added 2k plus 1, this is just an even number of times, it gets the point across, plus 2m plus 1. Okay, well, it's very clear that this is equal to, let's just go ahead and write down underneath here, that would be 2 times k plus m plus 2, right? But of course, this is equal to 2 times the quantity k plus m plus 1. Now, probably unnecessary, but the same thing would happen as long as you keep an even number of sum n's going on. Okay, so plus 1. So you see, that's a special case of this. This is two odd numbers added up, right? But the ones add up to give you 2. And if there's an even number of these odd numbers, a similar sort of thing happens. So anyway, the answer to the question is a big fat no. Because if we start with the assumption that it can happen and multiply through by the appropriate product here, we get an odd number on the left-hand side and an even number on the right-hand side. So the answer is no. Hope you enjoyed doing that one.